All right, so in section 7.8, we're going to be looking at graphing, square root, and radical functions. You'll definitely want to have your graphing calculators available, or use the app that I showed you on Google Classroom that you can download through Google Chrome. That is like a graphing calculator. So in this section, we're going to first look at what we looked at in chapter 5, which were quadratics, and then their inverse, which are our radical functions. So the first one we have is y equals x squared. So this is just your regular quadratic of parabola. We're going to jot down the domain and range. So who remembers what the domain of this function is? Remember, domain stands for the x values. So what are the possible x values? Remember, this graph goes forever and ever and ever left, and forever and ever and ever right. So our domain, we always said, was all real numbers. You also could write negative infinity to positive infinity. You can choose either or. Now the range is not going to be all real numbers because it does not go down forever. Rather, the smallest it ever touches is at 0. The largest it ever touches is infinity. So there's two ways you can write this. You can either put bracket 0, comma, infinity, parentheses. Remember, the smallest number goes first, largest second. Or you can also use an inequality, which would be y is greater than or equal to 0, because the y values are greater than or equal to 0. Now, when we look at the radical function, which is our main focus for today, notice because of the plus or minus, we will have a positive square root and a negative square root, which makes the sideways parabola. Remember that the inverse function, the domain and range, should switch. So the domain should be 0 to infinity, and the range should be all real numbers. Let's see if that makes sense. The x values start at 0 and go to the positive forever. So yes, the domain is 0 to infinity, or x is greater than or equal to 0. So if you're switching these, make sure you do switch the variable x. The range this time, the graph is going to go down forever, and it's going to go up forever. So the range is all real numbers, or negative infinity to positive infinity. Now, sometimes when we're doing these, we will restrict the domain so that the inverse is a function. Because right now, this is a function. It would pass the vertical line test. This one is not a function because it would fail the vertical line test. So sometimes we can restrict the domain so that it remains a function. And what we do is we just throw in a little stipulation. Say that x squared has to be greater than or equal to 0, which just gives us half of a parabola. So the domain then is restricted as well. It's from 0 to infinity, or you could also just write x is greater than or equal to 0. You'll see both formats of this on the mini quiz, so make sure you feel comfortable identifying both. The range, the smallest it ever touches on the y-axis, is 0. The largest is infinity, so the range would also be 0 to infinity. 0 gets a bracket because it actually touches at 0. Infinity, we never reach it, so it gets a parenthesis. Alternate, y is greater than or equal to 0. And then for our inverse function, which is just a positive square root of x, first of all, I want you to notice something about kind of like the pattern that occurs here. So it starts at 0, 0, and then it goes up 1 over 1. Then it goes up 1 over 1, 2, 3. Now that can be found by just plugging in numbers. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So the next one would be at 9. The square root of 9 is 3. But if you memorize this pattern, the up 1 over 1, up 1 over 3, it will make it faster to graph for you. All right, going back to our domain and range. The domain, again, smallest x value is 0. Biggest x value is infinity. X is greater than or equal to 0 is the alternate. The range, the smallest the y ever gets is 0, and the highest is infinity again. So these ones actually stayed the same. And the last type of function we're going to look at today are cubic and cube roots. So a regular cubic function looks like this. We learned this in chapter 6. It technically goes left forever and right forever, and up forever and down forever. So the domain and range should be all real numbers. When you look at the inverse, which this is what we'll be seeing in asked to graph today, the cube root of a variable, all that it does is it gets reflected across the line y equals x. So it's kind of a sideways looking S shape. But it still goes left forever, right forever, making the domain all real numbers. And it also goes down and up forever, making the range all real numbers. So most students tend to like the cube root functions because, again, they have all real numbers for both. And if you notice some values here, we do have 0, 0. We have 1, 1 because the cube root of 1 is 1. And then we have negative 1, negative 1 because the cube root of negative 1 is negative 1. Then the next value you would find would be at 8. The cube root of 8 is 2, so you'd have to go all the way out to 2, 4, 6, 8, and that would finally come up to 2. And the cube root of negative 8 would be negative 2, which would be over here somewhere. So the inverse of a function in the form y equals x to the n power, n can be any number, the 5th power, 4th power, 8th power. The inverse of it will be y equals the nth root of x. So just like we had x to the 3rd, the inverse was the cube root. If it were x to the 10th, it would be the 10th root of x. So today we're going to be asked to graph these. Again, on your homework, it's going to be matching multiple choice because you don't have graph paper, but all of the rules we learned in chapters 5 and 6 still apply. So these were transformations and how the graphs are manipulated. So remember, a reflection across the x-axis occurs if there's a negative outside of the square root, cube root, whatever. So it'll reflect across the x-axis. Remember our stretches and our shrinks. Our stretch is if the a value is bigger than 1. And a stretch would take like a square root function and it would make it look steeper. Whereas a shrink, which is if the a value is between 0 and 1, would make the square root look less steep. Another way to see reflection and a stretch would be if you had a negative a value. And then this is the one that usually you guys mess up. Remember, if it has a minus inside, that this actually goes to the right. And if we were to see, let's change this over here to a plus h. So if this were a plus h, that would actually tell us to shift this to the left, h units. So remember, these ones are under the radical or inside the parentheses. These go the opposite direction that you would normally think. Whereas vertically, plus outside tells us to go up that many units. Whereas if it were minus k, that would tell us to go down. Let's go ahead and change this one to a minus. And then you can have a combination of these, which would be shifting right h units and up k units, or left and down. All right, so to graph these, we can use our calculators, but I'm also going to use the translations. So we're going to graph this first one, square root of x plus 5 on the outside. Is that going to shift it 5 units up, down, left, or right? What do we think? Outside is up. Perfect. Minus 7, what would that shift it? 7 units to the down. All right, so you can use your graphing calculators. Obviously, will help you a lot. If you're doing this, make sure you arrow out of the square root before you put your plus 5. Start out with your zoom 6 to get a good window. You can see it has been shifted up 5 units. You can also use your table to get some points on there. So 0, 5, 1, 6, and 4, 7. I'll go ahead and plot those. 0, 5, 1, 6, and 4, 7. and then connect the dots to make that kind of shooting star. Remember the pattern I talked about on the front of the notes? If it's a regular square root that doesn't have a stretch or a shrink, it will follow this pattern of up 1 over 1, up 1 over 3. It doesn't continue going up 1 over 3 though. So that's just to get you like the next 2 points quickly. All right, now the next one should be shifted down 7 units. Let's go ahead and type that in our calculator to see. It has indeed been shifted down 7 units. Let's go to our table, second graph. Getting some points, we should be able to plot 0, -7. 1, -6. 4, -5. You can see again, this one has the same shape to it. I just labeled these y1 and y2 to be different. Then on your homework, I'm going to ask you a lot about the domain and range of each of these. So it wants you to find the domain and range of the second one, which is our y2. The square root of x is -7. So the domain, remember the restrictions on the domain are that the radicand can't be negative. So really this x value has to be greater than or equal to 0. So that's one way you can write it. Or you can use interval notation. The smallest the x value ever gets is 0. The biggest it ever gets is infinity. So bracket 0 to infinity. Or x is greater than or equal to 0. Now our range is our y value, so you're now focusing on the y-axis. What's the smallest it ever gets on the y-axis? And that occurs at -7. And then it's increasing forever, so we should have bracket -7, comma, infinity. The other way you can write that is y is greater than or equal to -7. All right, example 2, we see that we have subtraction addition underneath the radical this time. So notice this -1 underneath should be telling me to shift this to the right 1 unit. And this +4 underneath should be telling me to shift to the left 4 units. So again, you can either use the pattern and just shift right 1 unit and then count up 1 over 1, up 1 over 3 to get your starting points. Or you can use your graphing calculator to help you. Now this time you want to make sure that you are under the square root. We'll zoom 6. So we can see that it indeed has been shifted. Just doing that. Shifted to the right one. Again, go to our table, second graph, and we can get some points to plot. So 0, 1, 5, 2, and 10, 3. Two. 10, 3 is not going to fit on there. And then for my left 4, I also can go to my graphing calculator, change that to a +4. It has been shifted indeed to the left 4 units. And I can get some points by scrolling through my table. -4, 0, -3, 1, and 0, 2. Again, I just labeled the tip of that arrow y2 just to show the difference. Go ahead and pause the video, see if you guys can find the domain and range of this function on your own. When you're ready, press play and I will explain it for you. All right, so for our domain, we should be saying that x is greater than or equal to -4 or -4 to infinity. And our range, the smallest y value is 0. The highest is infinity. So 0 to infinity, or y is greater than or equal to 0. All right, our next couple examples, we're going to see multiple translations going on at once. So these are called combined transformations. Notice that, again, a vertical stretch is when a is greater than 1. That's when the square root graph is going to look almost steeper. And a shrink is when a is between 0 and 1, like a fraction or a decimal. It will be kind of flatter looking. So in example 3, we can see we have a stretch of 3, which means our graph should be steeper looking. What's this plus 2 do here? Is that left 2, right 2, up 2, or down 2? Should be left 2. And our minus 1 outside is telling us down 1. Now again, most of you are going to use your graphing calculators to assist you, especially since you don't have graph paper, unless you printed them out. So we'll just type them in, 3 square root x plus 2. Make sure you arrow out of the square root before you put your minus 1. We'll press our graph, and sure enough, it has, looks like it went left 2. It doesn't really look like it went down 1, but it did. Promise, if you go to your table, you will be able to see that clearer. It is at -2, -1. So I'm going to go ahead and just jot down those points in a little table here. So we had -2, -1, -1, 2, and 2, 5. I also put 7, 8. I don't know if that'll fit. Then all you have to do is plot those points on your graph. You don't have to actually write them down. You could just look at your table and then graph up here. We should have -2, -1, -1, 2, 2, 5, and then 7, 8. Connecting our dots. There's our graph. Okay, now for our domain. Again, we're thinking about the x-axis. What's the smallest it ever touches on the x-axis? Right here, -2. So it should be -2 to infinity. So bracket -2 to infinity. Or you can also write x is greater than or equal to -2. Our range this time, we're looking at the y-axis. What's the smallest it ever touches on the y-axis? That's at -1, and it's increasing forever, so -1 to infinity. Or y is greater than or equal to -1. If you're feeling confident, go ahead and try the next one on your own and pause the video. You can come back and see my answer at the end. If not, stay on and I will go over this one. So this 1/4 we see here as a fraction is telling us that it is a shrink of 1/4. The -2 inside is telling me to shift left or right. Remember, normally we think negative would go to the left, but it's the opposite direction, so that'll be right 2 and down 4. And we can use our graphing calculator to, again, get us some values. In your calculator, you'll just type 1 divided by 4. If you want to put parentheses around that, you can. Then we'll have, oops. Let's try that again. 1/4 times the square root of x minus 2. Arrow out of our radical and -4. Now it makes sense. This looks really flat because it is a shrink. And that's what it should look like. Looks like it did go right 2 and perhaps down 4. Let's look at the table though, get a better look. All these errors means the graph does not exist there, which is a restriction on our domain, so that can help you too. But 2, -4, since all of these are decimals, I actually am going to write down some of the decimals in my table. So I did 2, -4, 6, -3.5, and then I chose 11, -3.25, because this is not increasing at a drastic rate. Now all we have to do is plot those points. Again, these will be estimates for the decimals, so -2, 4, or excuse me, 2, -4, and then 6, -3.5, and that's really all I'm going to fit on there to be able to sketch it. Try the domain and range on your own. Go ahead and pause my video. Press play when you're ready. So the smallest it ever touches on the x-axis is at 2. So it should be 2 to infinity. Bracket 2 to infinity. Or x is greater than or equal to 2. For our range, we're looking at the y value. It's the smallest y value it ever touches, and that's -4. It is increasing, so it should be bracket -4 to infinity, or y is greater than or equal to -4. Now our last two graphs that we're going to take a look at pay attention because they switch from square roots to cube roots. So put a nice big star. Cube roots. Cube roots, if you remember, look different. They are not the shooting star. They are the S-shaped curve. Okay, the transformations are exactly the same, but the graph itself will look very different. So this one right here, first of all, is kind of rearranged. So I'm going to rearrange that to be negative cube root of x plus 1, and then put a plus 3 at the end so that that transformation is actually in its right spot. So the negative tells me that this is a reflection. The plus 3 tells me up 3. And the plus 1 inside tells me left 1. So remember, a reflection means that the graph will be reflected across the x-axis. So the graph will actually go like this instead. Should we use a different color there? But we're going to use our graphing calculator anyways to help us. So on the graphing calculator, hopefully you guys remember how to get your cube roots. Let's go to our y equals button. So to get our negative sign, I'll press the negative button. And then our cube root, we go under the math menu. And option 4 for cube root. And then underneath, x plus 1. Arrow out, and I'll put my plus 3. So that's how I rearranged it. You also could type in the original, it doesn't matter. And as I said, you'll see that this square root curve has been reflected. Again, let's go to the table to get some values. So here are some nice values for negative 2, 4, negative 1, 3, 0, 2. And I just wrote down as many as I could that were whole numbers. And then go ahead and sketch those on your graph the best that you can. The domain and range are everyone's favorite for cube roots because it goes left forever and it goes right forever. So the domain is all real numbers, or negative infinity to positive infinity. The range, it goes down forever and it goes up forever. So that's also all real numbers, or negative infinity to positive infinity. Uh-oh. Kind of getting a sneak peek at my next graph over here. Let's see if I can bring this up. And then the last one, notice this also is a cube root function. So this should have a similar looking shape. It has not been reflected though. So it should be the regular S-shaped curve, not reflected. We should have a stretch of 2. This is telling me to go left 2, and this is telling me to go down 2. So stretch 2, left 2, down 2. But as I said, most of you are going to use your graphing calculators to assist you with this. So just make sure you're typing it in correctly. So we should have 2. Again, to get your cube root button, press the math key. Option 4. X plus 2. Arrow out of your radical and press minus 2. And again, we can see that little graph occurring here. And then we'll just go here, get some values. So negative 10, negative 6, negative 3, negative 4, negative 2, negative 2, negative 1, 0. That might be all I can fit on there, because I am going to get some big numbers after a while. And all I have to do is plot them the best you can. So negative 10, negative 6, negative 3, negative 4. And then you will see this stretch factor kind of takes place in the middle. It did go like up 2 over 1 and it went down 2 over 1 from where it was located. Notice it was shifted left 2 and down 2. This is kind of like the middle point of the graph. That's where the shifting is taking place. Domain for these is all real numbers again, because it goes left and right forever. It goes up and down forever. So all real numbers, all real numbers. On the mini quiz, if there are any that don't ask you to graph and they ask for the domain and range, I suggest you use your calculator to graph so that you can visually see the domain and the range. All right, the last couple questions are asking us to rewrite the given function to make it easier to graph using transformations and describe the graph. Right now we cannot say that this is shifted left 18 because of this 9 that is there. So the first thing that you can do here is you can look for a GCF. The GCF underneath the radical is 9. So we can factor that out of each term. Now leave it under the radical for right now, because if we redistribute 9x plus 18, that's what it would look like. Then we can actually take the square root of 9. The square root of 9 is 3. That 3 will come out front. That is now described as a stretch. Okay, so this would be a stretch of 3. And then the plus 2 tells me to shift what direction? Left. Good, so the parent function y equals the square root of x has been shifted left 2 with a vertical stretch of 3. In 8, we have a cube root, but that doesn't change anything about the transformations. Again, take out a GCF. This time we can take out an 8. Underneath, we're only looking at under the radical. This plus 3 outside just stays where it's at. And then we can actually take the cube root of 8. What is the cube root of 8? 2. That 2 then comes outside. So we should get a vertical stretch of 2. The minus 3 inside tells me to go to the right 3. And the plus 3 outside tells me to go up 3. So right 3, up 3, and a stretch of 2. All right, I'd like you guys to go ahead and try the closure questions, which are multiple choice test prep. Go ahead and pause the video right now, and I will go over them in just a few short minutes. So press pause until you're ready. So for 71, we should have picked A. It was shifted 7 units left because it was plus 7 underneath. 72, we should have picked J. Minus 5 is down 5. And for 73, we're looking for one that shifted 4 units up, which would be plus 4 on the outside, which were these two. I eliminated A and D. And then 3 units to the right would be B. This one would have been 3 units to the left. So the answer was B. Make sure after you're completed with your homework, if you guys have questions, email them to me before taking your mini quiz.